Now that we've got our film loaded into this canister, we can develop it so that we can see what we shot. So as I said in the last video, the top to this canister is light tight, it's baffled, so that you can put fluids in and take fluids out without actually exposing the film inside to light. So this cap comes off. The first thing that you want to do is put some plain water in here. And this is to let the film soak and soften so that it will be more receptive to the chemicals. So I'm going to do what's called a dry run. I'm not going to actually process the film here, but I'm going to show you the process. So the first thing that I will do is pour water in. This tank, which has a single reel in it, holds 8 ounces of fluid. So I'll pour 8 ounces of water in, like so. I hold this at an angle for the water to go in. If I hold it flat, an air pocket forms and the water or the fluids will just kind of pour out. So I hold this at an angle and I pour in 8 ounces. I cover it up and I invert it a few times to make sure that the water is in there and getting to the surfaces, and then I give it a nice hard rap or two to dislodge any air bubbles. So if there are air bubbles on the film, the fluids won't get to those areas, and then you'll have these little dots of undeveloped film, which you don't want. So we have the pre-soak water in, and we can set this aside. And I've got containers for the different chemicals. We'll be using actually five different chemicals, but 3 at first. The first is called developer, because this chemical develops the film and it makes the latent image that was formed on the film when we exposed it to light visible. It does that by converting the silver halides, or those silver compounds that are embedded in the film, to silver metal, to the extent that that area was exposed to light. So perhaps you've seen when you look at film, some areas are dark or dense, some areas are thin or clear. So the dark or dense areas are the areas that received a lot of exposure, a lot of light. And so a lot of silver metal is deposited there. The clear areas, or the lighter areas, were the shadow areas where not as much light exposed the film. And so not as much silver metal will be deposited there. So the developer, all the chemicals are supplied. The developer is here in this cupboard, and you have to dilute it, and you have to measure the temperature. So it's very important that you know the specific temperature of the developer. All photochemicals should be between about 65 and 75 degrees Fahrenheit. Cooler than 65 degrees and the molecular motion kind of slows down, and the development doesn't, or any of the chemical reactions are not as consistent. Hotter than or warmer than 75 degrees, or at least 80 degrees Fahrenheit, then the molecular activity increases so much that it's difficult to control the developing process. It happens too quickly and unpredictably. So you want to know what the temperature is, because the developing time will be determined by the temperature. So the warmer the fluid is, the shorter the developing time, and the cooler it is, the longer the developing time. So we have thermometers, and what you'll do is take 2 containers and take the temperature of the developer. You'll pour 4 ounces of developer into one graduated cylinder, a measuring container, and 4 ounces of water in another from the tap. And you want to know what the specific temperature is. So if it's very cold in the dark room, let's say it's in February, and you take the temperature of the developer and it's at 60 degrees, that's too cool. So you'll want to use warmer water to warm up the developer. So let's say the developer is at 65 degrees and you want it to be 68 degrees. So you want to raise it by 3 degrees. In that case, you need the water to be 6 degrees warmer than the developer so that they average out. So again, if the developer is at 65 degrees, for example, then you would want the water to be at 71 degrees so that they average out to 68 degrees. And 68 degrees Fahrenheit is the optimal temperature for processing film, for developing film. You can do 65, but 68, 70, 72 are the best temperatures. So let's say we've gotten these to 68 degrees. We mix them together so that we have a total of 8 ounces for this container. There's a chart on the wall that tells you how long to develop different types of film at different temperatures. So this particular film needs to be developed for 11 minutes at 68 degrees. And so there are timers up here, and I will set the timer for 11 minutes. But I don't want it to start quite yet. So I've set it to 11 minutes, and when I'm ready, when I've got everything ready, I'll pour out the soap water into the sink here, and then carefully pour in the developer. I'll cover it up, and as I'm doing so, I'll come over here and turn the timer on. And for the first 30 seconds, I'm going to agitate the film. I'm not going to shake it up like a martini. I'm just going to be gentle. Some people do a kind of figure 8 motion like this. And when I get to 30 seconds of doing this, I will, as I did with the soap water, give it a nice wrap to dislodge any air bubbles. Then I'll set it aside for 30 seconds, and then at the top of each minute, I will agitate for 10 seconds out of those minutes for the next 10 minutes. Obviously, I'm not going to stand here during this demo and do that, but as we get to the top again, I'll agitate for another 10 seconds and then set it down. As I said, I'll do that for 11 minutes. So that is the developing process. When that's done, you'll need to use something called stop or stop bath. And that will stop the action of the developer. So most photographic developers are alkaline or base, and so we use an acid stop bath to stop the action of the developer. You can use plain tap water because tap water is slightly acidic. Many photographers use an acid, for example, acetic acid. So we do have acetic acid here. We also have water. I'm going to use water. And so I will, at the end of the 11 minutes, as I get to 11 minutes for the developer, or whatever time your film will be, you pour out the developer and then pour in the water or stop bath, like so. And agitate it for about 30 seconds. Some people say 10 seconds, other people say a minute. 30 seconds should be fine. And you can then dump that out, like so. So the developer and stop bath get dumped down the sink. The next 3 chemicals do not. So we have now stopped the action of the developer, and the image will be visible on the film, but it's not safe to open it up yet. We need to use something called Fixer, and Fixer makes the image permanent and impervious to further change upon exposure to light by removing the unexposed silver left on the film. So that is what would turn black if you exposed it to light. So we want to remove that. So the next step is Fixer, and the chemical that we use is called sodium thiosulfate, or sometimes ammonium thiosulfate, and we supply that. There is, if you can see, there are 2 bottles here. It says here, fix, return to bottle. And so you will pour out 8 ounces of Fixer into a container and have that ready. You can do that while your film is developing. So I've poured out the stop, and I'll now pour the Fixer in, like so. That. Cover it up. You do not dilute the Fixer. Okay. And again, you'll agitate for the first 30 seconds, and then fix for a total of 5 minutes. So I don't know if you can see that clock, but 30 seconds agitation, and then, as with the developer, 10 seconds out of each minute thereafter. When you've finished with the Fixer, you will not dump it down the drain. You'll pour it back into the container that you had filled with Fixer, like so, and pour the Fixer back into the Fixer container. And now you'll rinse the film for maybe 30 seconds. It's now safe to open this up and take a look at it. You don't want to do an extended viewing, but you can check to see if your film has been developed. If it looks opaque, like so, it did not develop correctly. So what you want to see is the base clear, and you want to be able to see images on the film base. You also don't want to see any milkiness or areas that are kind of cloudy. So if they are, it means that the Fixer did not work correctly. So you want to put it back into the container quickly and close it up and tell your instructor, me, or Kevin, who runs the lab, or somebody that you think that the Fixer is exhausted or is not working correctly, and then you'll fix it again. But assuming that all is good, you've looked at this, you're then going to rinse it for about 30 seconds. You can just turn the water on, fill and dump a few times. And then you're ready for the last chemical that you'll use in the container, and that's something called HypoClear. We supply the HypoClear here, and again, you don't dilute it, and you do need to put it back into the same container. You don't dump it down the drain. So HypoClear removes residual Fixer from the film. Fixer is great stuff, but it's difficult to just wash out. It takes a long time to wash film and to wash photo papers to get the Fixer out. And so HypoClear is a chemical that helps to remove the Fixer quickly, and it cuts down the wash times by quite a lot. So instead of having to wash your film for an hour, you can wash it for a few minutes. So that's a great thing. So again, you will, after you've rinsed your film for 30 seconds or so, you'll pour in the Hypoclear. So, cover it up. And agitate continuously for 1 minute. And that's still going, that's fine, or you can reset the timer. And a nice gentle agitation for 1 minute. After 1 minute, and if you go over, it's okay, but you want to do at least 1 minute. After 1 minute, you'll pour the Hypoclear back into this container, and then the Hypoclear back into its container. And now you're ready to do a final wash. So we have film washers here, and I'll post some pictures of them. And you put the reel into it, and it's hooked up to a water source, to a faucet. So you put your film reel into the film cleaner, film washer, like so, and you turn it on. And the nice thing about the film washer is that it does an exchange of water. And you do that for 5 minutes. And then your film is all washed, and there's just, well, there are a couple things left, but one more chemical. And that's called PhotoFlow. And PhotoFlow is kind of like a really concentrated soap. And it releases the tension of the water. So we're going to be hanging up the film to dry. And without PhotoFlow, the water would form rivulets as it drains down the film. And that can leave water spots. And so the PhotoFlow, by releasing the tension of the water, allows the water to sheet down the film without forming rivulets. And so it reduces the likelihood of water drops. So there will be PhotoFlow mixed in a container, sink, and you will place your reel in here and just very gently agitate it for 20 to 30 seconds. That's all it needs. You don't want to do it quickly because, again, this is soap. It's very concentrated soap, and it'll get all bubbly, and then you will get droplets on your, stains on your film. So very gently, and then when you're done, you knock off the excess fluid, and then finally you will take the film to the film dryer, which is right there, right here. And you'll open it up, make sure it's turned off before you open it. Otherwise, dust gets sucked in, and dust is your enemy in photography. So you will come here, you'll hang up the film and weight the bottom, and there are clips to do so. And somebody left their film in here, so I can just show it to you. Oh my. So there's some film here. It's not very good. I can see why somebody left it, but there it is. And so it will hang in the dryer until dry, about 20 minutes or so. And then you will come back, make sure again that this is turned on before you open it. Right here. Take your film out. You'll then cut it up into strips and put the film into a film sheet, like so. And then you will have your film all ready to process, to develop, or to make prints from in the darkroom, which is the fun part. Okay,